In this lesson, we are going to build the basic picture of the atom. We will look at the three subatomic particles, protons, neutrons, and electrons, and compare where they are found, what charges they carry, and how their masses compare. We will also look at what happens when these particles pass through an electric field, because that helps us understand the effect of charge and mass. So we are going to study mass, charge, and electric field behavior of protons, neutrons, and electrons. All matter is made of atoms. An atom is the smallest part of an element that can take part in chemical reactions. But an atom is not just a solid little sphere. In fact, most of the atom is empty space. At the center, there is a very small but very dense nucleus. So when we imagine an atom, we should picture a tiny central nucleus with a lot of space around it. There are three main subatomic particles. Protons are positively charged and are found in the nucleus. Neutrons have no charge, so they are neutral and are also found in the nucleus. Electrons are negatively charged and are found outside the nucleus. At A level, we usually say that electrons occupy energy levels around the nucleus, although at simpler levels, these are often called shells. To compare subatomic particles, chemists use relative mass and relative charge. A proton has relative mass 1 and relative charge plus 1. A neutron also has relative mass 1, but its charge is 0. An electron has relative charge minus 1, but its relative mass is only 1 over 1836. So the electron is much lighter than the proton or neutron. Most of the mass of an atom is concentrated in the nucleus. That is because protons and neutrons are both found there, and each has relative mass of about 1. Electrons are much lighter, so their contribution to the total mass is usually treated as negligible. So, if a question asks where most of the mass of an atom is found, the answer is the nucleus. The nucleus is positively charged because it contains protons, while neutrons are neutral. Electrons are negative and are found outside the nucleus. So, what holds the atom together? It is the electrostatic attraction between the positive nucleus and the negative electrons. Opposite charges attract, and this attraction keeps the electrons associated with the atom. Quick check, which subatomic particle has relative charge 0? Pause for a moment and think. The answer is the neutron. Now, let's see what happens when these particles pass through an electric field at the same velocity. Electrons are negatively charged, so they are attracted or deflected towards the positive plate. Because electrons have very small mass, they are deflected strongly. Protons are positively charged, so they are attracted towards the negative plate. But protons are much heavier than electrons, so they are only deflected slightly. Neutrons have no charge, so they are not attracted to either plate and are not deflected at all. The difference in deflection depends on both charge and mass. A particle must be charged in order to be affected by an electric field, which is why neutron is not deflected. Among charged particles, the particle with a larger charge to mass ratio is deflected more strongly. Since the electron has the same magnitude of charge as a proton but a much smaller mass, its charge to mass ratio is much larger, hence greater deflection, which means it will bend more. As you can see, theta 1 is larger than theta 2. Quick check. Why is the electron deflected more than the proton? Pause and think. The key reason is that the electron has a much smaller mass. So it has a much larger charge to mass ratio. So to summarize, the atom is mostly empty space with a small dense nucleus at the center. The nucleus contains protons and neutrons, while electrons are found outside the nucleus in energy levels. Most of the atom's mass is concentrated in the nucleus. The atom is held together by electrostatic attraction between the positive nucleus and the negative electrons. In an electric field, the electron is deflected strongly, the proton only slightly, and the neutron not at all. If you want to learn more about A-level chemistry, be sure to subscribe to this channel, and I'll see you in the next one.